Guys, we're going to continue more stoichiometry today. This time we're going to do, these are going to be the longer problems. We're going to do mass stoichiometry. So we're going to start with the mass of one compound, end with the mass of another compound. So really it's just kind of adding a step to what we've already been doing. We're going to continue to use the mole ratio, all of that. I will upload last night's homework answer key at some point this afternoon, so make sure you've gotten that submitted to me through email or Canvas messages. Either one is fine. Okay, so I'm going to give you the balanced equation to make this simple. So we got calcium phosphide and 6 moles of water. Gives us 2 moles of phosphorus trihydride and 3 moles of calcium hydroxide. So here's our first practice problem. If 62.30 grams of water are used, what mass of calcium phosphide is required to carry out the reaction? So we are starting with our 62. So let me get to this. Okay. Hold on one sec, sorry. I'm going to turn on my pad here. Okay. So we're starting with our 62.30 grams of H2O. So again, as always, show your units and your formulas in your work. So we know we've got to go to grams of H2O. The molar mass of oxygen is 16, each hydrogen is 1.01, so that gives us 18.02 grams of water in 1 mole of water. So at this point, we've gotten rid of grams of water. We're moles of water. So we know that we're going to have to do moles of H2O down here. Since at this point our given compound is in moles, we know we have to do our mole ratio because we're trying to get to moles of calcium phosphide. All right, so let's look up here again and look at our mole ratio. So we have 1 calcium phosphide to 6 waters. So we're going to do our mole ratio, 1 calcium phosphide to 6 waters. Now we got rid of moles of H2O and we're in moles of calcium phosphide. But we can't stop there because it specifically asks for the mass of calcium phosphide. So now we're going to do another mole conversion and convert our calcium phosphide to mass. So we're going to go to moles of Ca3P2 down here. And we know that in 1 mole of calcium phosphide, we have, let me check this mass real quick. So we have calcium is 40.08, and we have 3 of those, plus we have 2 phosphorus at 30.97 each. So it looks like 182.18 to me. You guys can check my work, but I think that's good. So we got rid of moles of calcium phosphide. We are in grams of calcium phosphide, which is exactly what it asked for. So we're going to do our 62.3 times 182.18 divided by parentheses 18.02 times 6, close parentheses, and I get 104.97 grams of Ca3P2. So do that, check, make sure you get the same thing as I do. Let's do one other one together just to make sure. Our next one will be, if 400.86 grams of calcium hydroxide is produced, what mass of water reacted with an excess of calcium phosphide? So let's think about our given here. So that's always pretty easy to find in these. CaOH3. All right, well, before we do anything else, we know that we're going to have to cancel out grams of CaOH3, and that is going to be 3.03 plus 48 for the oxygen plus 48.08 for the calcium and I get 91.11 grams. Okay, and we know that's how many grams are in 1 mole of CaOH3. So let's see what it's asking for. Basically, in the long run, it wants what mass of water. And this is what mass of water reacted with an excess of calcium phosphide. So what that means up here is that we had plenty of calcium phosphide, so we don't need to worry about it. And we'll get into why that's important when we do limiting reactants. So that's all that's really saying. So really it's saying how much water did we have to use to get the amount of calcium hydroxide that they told us we got. So we're now in our moles of our given. Our given was calcium hydroxide. So we got rid of grams, we're in moles. Um, so now we're going to do our mole ratio step. So mole to mole of calcium hydroxide obviously goes on the bottom. And we're trying to get to moles of water. Let me go back up because I already forgot the ratio. Water 6, calcium hydroxide is 3. So 6 water, 3 calcium hydroxide. Now we got rid of moles of calcium hydroxide. Great. And we're in moles of H2O, but it says the mass of water. So in 1 mole of H2O, we have 18.02 grams of water. It's its molar mass. Remember, the only place you use those coefficients is in this mole ratio. Don't use it anywhere else you have moles. So let's do our math. 400.86 times 6 times 18.02 divided by 91.1 times 3 times 3. I'm getting 158.57 grams of water. Feel free to email me if I messed up my math anywhere, because I just threw the calculator quickly. So that's how we do mass to mass stoichiometry. So you guys check your assignment on Canvas and you should be good to go. But of course, email me if you have any questions, and have a great day.